No, it's okay. Good morning, everyone. Thank you very much to Orquídea and the Agricultural University of Iceland for having invited me and my colleague Julián Cuevas from Almeria, Spain, to be here today with you. As you can see, the name of my presentation has changed from what was just presented, because my first idea was to make a more technical lecture about what are the trends in technology in high-tech greenhouses. But then talking to the organizers, I realized that perhaps it was too technical, and that looking at the content of this meeting today, it was better when I would present the results of this study that I did myself together with another colleague when I was working until last year in Wageningen University. And this study was paid by a company called Earth 2.0, owned by David Wallerstein, which is CXO of Tencent. And he wanted to know if there was a chance for large-scale production in high-tech greenhouses or indoor farms in Iceland to export this production, and what were the challenges for it. I will try to summarize this. So high-tech greenhouses make it possible to grow in virtually any climate in the world. That's really nice. We have the technology to grow anywhere. Actually, I even myself made some calculations some years ago. I was invited to do a lecture in the Mars Society in Italy, and I made some numbers of for a greenhouse in Mars. So if we ever go there, we will need to produce vegetables, and we will need to build greenhouses or indoor farms. And so I made numbers of how these greenhouses would look like and how much energy they would need, and etc., etc. So really, we can grow anywhere with high-tech greenhouses, and we can even grow in the middle of the desert. This is a picture of a closed greenhouse in Abu Dhabi, growing cucumber. And recently, we got some numbers from colleagues in Wageningen that, they calculated in their trials that for 1 kilo of fresh tomato in the desert, it can be produced in one of these closed greenhouses with very little water, because all the water is recovered in the condensers, so only 4.2 liters, but with 8 kilowatt hours of electricity per kilo. So, well, you can produce anywhere, but it will take some amount of energy when the climate is extreme. In the case of Iceland, it's the lack of light, natural light, so we need a lot of artificial light, but we can grow also in this climate. And so the questions that we had before the study were which crops could be produced in a competitive way in these high-tech greenhouses or indoor farms in Iceland. How could productivity be improved by different technology? How is the use of resources affected by the variation in the climates in the island? And which potential for export markets can we consider? And so first we will see a little bit about the crop selection, then technical scenarios that were designed and how we did the calculation for the amount of resources needed. Then the cost calculations for the investment, the CAPEX and the OPEX, market selection tool and data collection, sorry. And then the integration of, on one hand, the cost price that we have calculated, and on the other hand, the possible selling price in different markets. And then with that, we can see which combinations could give a positive outcome for export. So for crop selection, we had really a large number of crops, and we made some constraints to make the selection of the most suited crops. Post-harvest life, possibility for mechanization. I mean, we named a number of criteria that we scored, and in the end we came up with a list of products. But then David Wallerstein, when he saw the list, he said, well, these products, they are not products with calories, the ones that provide quite a number of calories in the diet of a person. So we have some crops like tomato, lettuce, sweet pepper, raspberry, which we know that the greenhouses give a competitive advantage. Then we have some like avocado or banana, which we know maybe possibly could be grown also in high-tech greenhouses successfully. And then there are some strategic crops because of the importance that they have for the daily calorie input in human diet, like wheat, rice, or potatoes. And we analyzed 3 different technical scenarios, and that was studied in 2 different locations. So for glass houses, we looked at artificial light with HPS lamps and 2 different locations, Keflavik and Akureyri. But we also looked at the alternative to use LEDs in the same 2 locations. And then we also look at the possibility of building indoor farms. Of course, in this case, only LEDs are the option. And well, with an indoor farm, it doesn't really matter where you install it in terms of the effect that the outside climate can have on the production, because we are perfectly insulated from the outside conditions. The design of each of the technical scenario was based first on a climate data analysis and then on the experience that we have on what type of technology is needed looking at the climate. For most crop site combinations, we also analyzed different artificial light intensities. How did we do the calculation of the potential productivity? Well, we used for that models. We used very advanced greenhouse climate indoor farm models to calculate how many resources were required to maintain the desired conditions inside the greenhouse and the indoor farms. We coupled to these models crop models for tomato and lettuce, and for other crops we estimated based on the photosynthesis, because there are not crop growth models available. And then from there we could obtain the amount of electricity, CO2, energy for heating, water, as well as an estimation of the amount of kilos that could be potentially produced. Here we have an example of the effect of the location, the lighting, and the growing system, taking as a reference the scenario where we are in Keflavik in a glass house using high pressure sodium lamps with an intensity of 100, well, I don't know exactly which was the intensity, but that would be the reference, so 100. And then we see, for instance, if we are in Keflavik and use LEDs, then we use less electricity, but we use more energy for heating, of course, to compensate for the fact that LEDs supply less radiative heat, etc., etc. We see also that there is not such a huge difference in terms of energy, electricity between the 2 locations, Keflavik and Akureyri, so climate is not so different. But here we can see, well, the different numbers that were obtained for resource use. And then, in order to estimate the OPEX, the operational costs, we used a methodology developed in Wageningen, which gives every 2 years there is a publication called Quantitative Information for Glasshouse Horticulture. It's something that you can buy on the Wageningen website, and it gives you, this publication gives you all the numbers for Dutch horticulture for different crops, both operational costs and capex, etc. So same methodology was used. We collected data locally with the help of Earth 2.0, and then we could establish the cost distribution for the different combinations. Here, for instance, we see an example would be a glass house for tomato using HPS lamps with an intensity of 250 micromoles in Akureyri, and we can see that, well, most of the money has to go for paying the capex, and of course, as you could imagine already, electricity and labor are the major costs. So, of course, anything that can help in decreasing electricity and labor cost is welcome. In terms of labor cost, we have to say that luckily, this is also a problem for Dutch growers and for, in general, all high-tech greenhouses in the world. That means there is a lot of money being put nowadays into research to try to decrease labor costs. That means we are getting more and more investigation and innovation in robots that will in the future be taking over some tasks like harvesting the fruits, de-leafing, etc. So this is something to have an eye on, and also to maybe invest as a country in robotics for greenhouse tasks, because this is something that is very important to maintain the benefit. And electricity, well, that's a matter of negotiating in the case of Iceland with the power plants and see if you can get good deals in the price of electricity. With this we calculated the cost price in Icelandic crowns per kilo, and this is the best case from all studies, let's say. Perhaps, well, if there are any growers here, they might consider that the number is not exact, but we think the numbers are quite close to what you find in reality. And you will see that for some crops like wheat, rice, and so on, the cost price is enormous. And that I will explain now the reason why. And it's because the nutritious crops basically have very little water. That's the reason why the cost price is so expensive, because a lot of people ask me all over the world, how is it that we make such good money from lettuce and tomato and greenhouses and sweet peppers? Well, it's easy, because basically we sell a lot of water with some vitamins at a very good price. But that's why we can produce many kilos per square meter and make good money. The other crops, like wheat or rice, basically, as you can see in the numbers, they are basically dry matter, concentrated dry matter. They have very little water. That means the productivity per square meter is quite low. So even if we grow those crops in a high-tech greenhouse and we can increase a lot the yield, the double of very little is still very little. Okay? So in the end, it is really not profitable to grow crops which have low water content in greenhouses. There are some exceptions, of course. I'm thinking about vanilla, saffron, some crops which are really very, very valuable. And then, of course, you compensate the low productivity by the very high price that you pay per kilo. So after that, we made the market selection methodology. Well, for this, there were several indicators used, like import price, import development, etc. And the 8 most promising markets were selected for each crop, and then the combinations were studied, looking at the wholesale and producer prices and the transportation cost by sea and air freight. And here we see some examples. For instance, this could be for lettuce, and we see the wholesale price of the lettuce in different locations and the transport price, and we see that indeed for lettuce this would be a positive case. So lettuce is one of the crops for which export seems to make sense. Another crop for which export would make sense would be berries. We see that for most markets there would be a profit by exporting berries from Iceland. So this says that, of course, air freight costs seem not to ensure much potential for the other crops like tomato, etc. I have to say that yesterday I had an interview with one tomato grower, and he said that he had successfully exported tomatoes to some destinations like Greenland and Faroe Islands, etc. So perhaps this conclusion that we made in this study has to be reviewed, because it might be that there's still hope for some crops to be exported successfully. But of course, in principle, it needs to be to markets where the final price is also high, like here in Iceland. There we see some of the crops which are suitable for sea freight, like banana, and we see that, well, the problem is that all the red part are costs which are in excess to open field production. That means that, well, there is little room for growing bananas at the wholesale prices that we saw in the market study. There is little room to grow them for export with a benefit. So, as a summary, we have evaluated the best design investment dependent on local and climate input costs. We evaluate how productivity can be enhanced through some technical investments. We do wide productivity could be increased by also application of artificial intelligence or improved breeding, and also by AI in general applied to the whole production process. And we have assessed the potential to export to countries based on import price and GDP, import volume and trends and tariffs. And conclusions is that the cheap and sustainable energy of Iceland gives a potential competitive advantage only for the crops which are already cultivated in greenhouses anywhere else in the world. But then many of these crops require air fry, and I say they are really, because, and this is also a conclusion for which I think it's too heavy. I think there is also possibility to do sea fry with success for some crops like tomato. Potentially competitive crops are very high value ones, such as raspberry and lettuce, that's obvious. And glass house production, not indoor, has in all cases the lowest case price. Also glass house production for the internal market might still be profitable and could be expanding. And I have two slides here that show that you still in Iceland rely heavily for vegetables on imports. There are some crops like cucumber for which you are self-sufficient, but for the others, or many others, you are still not. So there is room to import, to produce locally still with a profit crops like bell pepper, like zucchini, like many others, melons, etc., and make money. So just need some, I guess, some entrepreneurs willing to do the business, and also a good link to the knowledge institutions that can help by making research and trying to help them in deciding what is the best technology, etc. But this is my conclusion.